Hello and welcome to helpyourmath.com. In this video, we're going to look at translating and solving English sentences into algebraic equations with a focus on interest problems. Let's get started. First, before we actually read this, I need you to take a deep breath, go and out. You can do this. I know these can seem very complicated and stressful. You can do this. Okay, Stanley has money invested in two accounts. All right, what are we going to call our two accounts? Sometimes I like to use the variables of the interest earned on them, or you can always use X and Y. It doesn't matter. Let's keep reading. He earns 7.1% interest in one account and 10% interest in the other account. He has 3 times as much money invested in the account that pays 10% than the account that pays 7.1%. And the interest earned from both accounts after 1 year is $1,298.50. Wow, that's pretty sweet. How much money does Stanley have invested in each account? Okay, so what we're going to do is I'm going to call the account that with 7.1% interest, I'm going to call that S. And the account with 10% interest, I'm going to call T. So what do we know about S and T? Here's one thing we know. He has 3 times as much money invested in the account that pays 10%. So that means whatever he has invested in S, let's say it's $1,000, he has 3 times more in T, or $3,000. So how can we represent T in terms of S? Well, we would say that T is equal to 3 times S, right? Because he has 3 times as much more money in the account that pays 10% interest. Okay, and then we have our S. Okay, what else do we know? The interest from both accounts is $1,298.50. So how much interest did he get in the account with 7.1% interest? Well, that would be 7.1% times S, right? That would be the interest earned in that account. How much interest did he get in the other account? That would be 10% times however much is invested in the account that pays 10%. What we know is that if we add those together, we know what the total is. Now, unfortunately, we can't use 7.1% as a percent. We need to convert it to a decimal or a fraction. We can convert it to a decimal by moving the decimal point 2 places to the left. That gives us 0.071 times S. That's a usable number. And same thing with 10%. So 10%, we move the decimal 2 places to the left, we get 0.1 times T. So now we're going to add these together. Well, we're going to write an expression where we add them together. 0.01 times S plus 0.1 times T. And we know that this equals $1,298.50. Okay, wait, but we have one equation with 2 variables. That's not good. How can we get rid of one of these variables? Aha, we can go back here. We have T is the same as 3 times S. So what we're going to do is we're going to substitute in where we see the T here, we're going to replace it with 3 times S. So that would be 0.071 S plus, and instead of 0.1 times T, we're going to replace it with 3S is equal to 1,298.50. And if you want to just preemptively get rid of the decimals now, you can do that. If you want to wait, you can wait. Might as well just get rid of them now. How are we going to get rid of these decimals? Where's the least place in any of the decimals? Right there, that 1 is in the thousandths place. So we need to multiply every term by 1,000. I'm going to multiply every term by 1,000. What that's going to do is it's going to move the decimal point 3 places to the right. 1, 2, 3, giving me 71S. Plus, I move it over 3 times, 1, 2, 3, 100 times 3S, and 1, 2, 3, 1, 2, 9, 8, 5, 0, 0. Okay, let's clean up the left-hand side. This would be 71S plus 3 times 100 is 300 times S equals 1,298,500. Adding these values together gives us 371S equals 1,298,500. Last step, divide both sides by 371. I hope you have your calculator handy. And when we divide by 371, we should end up with 3,500. So we get S is equal to 3,500. And if there was 3,500 invested in the account with 7.1% interest, how can we figure out how much was invested at 10%? Well, we know it's 3 times more. So we're going to multiply by 3. And when we multiply by 3, we get $10,500. Oh, that looks like an extra 1. Sorry, $sign. Let's try that again. $10,500. And you might be saying, ooh, okay, that was a lot. But really it wasn't so bad, was it? And we can always check our work. So if we want to check our work, what we would do is we would do 3,500 times 0.071, and that gives us $248.50. So presumably from that account that pays 7.1% interest, the interest earned was $248.50. From the other account that paid 10% interest, we're going to take 10,500 and multiply by 10% or 0.1. That gives me 1,050. And then if we add these together, hopefully we end up right up there. Let's see, we're going to end up with 1298.50. It works, yay! So I feel pretty confident that we set these up correctly and got the right answers. One more example. Phyllis has money invested in 2 accounts. She earns 3.6% interest in one account and 6% interest in the other account. She has $2,500 less invested in the account that pays 3.6% interest than the account that pays 6% interest. And the interest earned from both accounts after 1 year is $822. How much money does Phyllis have invested in each account? Okay, so let's break this down step by step, or sentence by sentence. Phyllis has money invested in 2 accounts, so we're dealing with 2 things here. One, we know she earns 3.6% interest, so I'm going to use T to represent that. And the other is 6, so I'm going to use S to represent that. Okay, so T is the 3.6 and S is the 6%. Now the other thing that we know, I'm going to skip over the first part of the next sentence. We know the interest earned from both accounts after 1 year is $822. So how much interest does she earn in the account that pays 3.6% interest? Well, she's going to earn 3.6% of however much money is invested. So we can say 3.6% times T. And she would earn 6% interest in the account that she has S dollars in. Now again, just like in the previous problem, we can't actually use these percents. So we need to convert out of percent form by dividing them by 100. Dividing by 100 is going to move the decimal 2 places to the left, giving me 0.036 times T and 0.06 times S. Okay, so what we know is that, okay, the interest is $822. So here's the interest from the account that pays 3.6. Here's the interest from the 6%. If we add those interests together, that's going to be $822. So we're going to say the interest from this account plus the interest from this account is equal to $822. And we have this problem again. I have one equation and 2 different variables. Now let's go back to right here. She has $2,500 less invested in the account that pays 3.6% interest. So the account that pays 3.6% interest, she has $2,500 less. That means however much is in this S account, if we subtract $2,500 from it, that will tell us how much is in T. So just like in the previous example, we're going to use substitution. We know that T is the same thing as S minus 2,500. So in this equation where I see the T, I'm going to replace it with S minus 2,500, giving me 0.036 times S minus 2,500 times, no, just kidding, I was going to say times T, but we just substituted it out, plus 0.06 times S is equal to 822. Now is as good a time as any to get rid of those pesky decimals. To get rid of the decimals, find the smallest place. So here's a thousandths place. So we're going to multiply everything by 1,000, and that's going to clear out all the decimals. Multiplying by 1,000 means we're moving the decimal point 3 places to the right. So that'd be 1, 2, 3. This gives me 36. It leaves this factor unaffected because we just multiplied this term. You pick which factor you want to multiply by. Then in the second term, we're going to multiply the 0.06. That's going to be 1, 2, 3. That's going to be 60S. Be really careful with that because we are multiplying by 1,000. It's not 6S, it's 60S. And then 822 times 1,000, we'll add 3 zeros to the end of that. That's going to be multiplying by 1,000, giving us 822,000. So now we're going to distribute the 36. We're going to clean up the left-hand side by distributing the 36. Distributing 36, we get 36S minus 90,000 plus 60S is equal to 822,000. And we combine like terms, and I'm going to add 90,000 to both sides. So I'm going to do 2 things here. When I add these together, 36S plus 60S, that's going to be 96 times S, is equal to 822,000 plus 90,000 will be 912,000. Now we're going to divide both sides by 96. And when we do that, we figure out that in the account that pays 6%, we have $9,500 invested. 9,500. Oh, too much. Put that dollar sign in front. Okay, so now we know that $9,500 was invested at 6%. How can we figure out how much was invested at 3.6%? Well, remember, we can just use this right up here. We know that T is equal to 9,500 minus 2,500, which would give us 7,000. So we know that the 3.6% account, there was $7,000 invested. And the account that pays 6%, there was $9,500 invested. Let's just make that look a little prettier. There. These have been examples of computing interest when we have two accounts, so therefore two variables. Thank you for stopping.